The next thing we're going to look at is what's called the inverse of a matrix. So we're going to be trying to solve problems like this one, an equation a times x equals b, which looks simple enough, except for us, we're going to have a, x, and b represent matrices rather than just numbers. So in particular, if x is our unknown, it's an unknown matrix, and if we want to solve for that unknown, we're going to have to figure out how to do something like isolating x in this equation. Now, if these were all numbers, then it would be pretty simple. We could solve for x in the equation ax equals b just by using division. We could divide both sides of that equation by the coefficient a. That allows us to cancel the a's on the left side, giving us x isolated on the left side, so x is equal to b divided by a. Easy enough, but you cannot do that when your unknown and your coefficient matrix A is a matrix. Division only works with numbers. There's no such thing as dividing by a matrix. But there is something similar we'll be able to do. Here's another way to think of the algebra we just did. You have an equation, again, think of these as just numbers for the moment, and instead of dividing both sides by a, we'll multiply both sides by the reciprocal of a. So remember, with numbers, these are equivalent ideas. Dividing by a number is the same as multiplying by its reciprocal. So the property that makes the reciprocal useful here is that a number times its reciprocal gives you 1. And 1x is the same as x, so we've isolated x in this equation. X is the reciprocal of a times b. And that's equivalent to the answer we got using division, b divided by a. It's just another way of writing it when you're talking about numbers. And it turns out there's something we can do with a matrix that bears a resemblance to a reciprocal. So it's not exactly the same. It's not a reciprocal, because if you have a fraction, it doesn't make any sense to write 1 over a fraction. Or, a matrix. You can't write 1 over a matrix. But what we can do is find another matrix. So just like when you have a number, the reciprocal is another number. Given a matrix, we'll find another matrix, so that when we multiply these together, a and this thing that we're writing in a way that looks like a reciprocal of a, we're not going to get a number, but we're going to get another matrix. And if we can arrange it so that this product gives you an identity matrix, then we're going to be able to simplify in a similar way to what we did at the top of this slide. In particular, if we start with a matrix equation, matrix A times matrix X equals matrix B, and if we can multiply both sides by this thing that's playing the role of a reciprocal, then it will have the property that multiplying by A gives us the identity matrix. And then we can see identity matrix times X is just X. We've isolated X. We can write X as this new matrix times B. And now we just have to make sense of this new matrix. What is this thing that looks like a reciprocal? Well, it's actually called an inverse. If you have a square matrix, then you can look for another square matrix of the same size that will satisfy the property that the product of A and its inverse is the identity matrix. Not every matrix has an inverse, but many do, and we'll see in an upcoming lesson how to go about calculating it.